Hey, welcome back. We're talking programming again today, and I'm excited to share with you one of my newest projects, my very own Sudoku. I've been working really hard in these past couple of months. I'm working full time, I'm going to school full time, and in looking for future employment, I'm also working my tail off on side projects. So, this side project has been a little bit of just plain working on keeping functions smaller and how to create a more complex algorithm. And the real point of it is that hopefully I can turn this into a bit of a game where you can save boards, share boards, you can create your own profile, that kind of thing. I want to add a full-on backend to it. Leaderboards, it's going to be really cool. I've got plans. And that's all just practice for the backend programming that I want to do as well. For now, though, I wanted to share with you the algorithm that I came up with in order to create my Sudoku. So real quick, let's just take a look at it and see what features are currently built in. Do know that these features are not necessarily complete, and you may or may not find a bug or two as you're playing. Some of the features that you can find. First off, you can pause it so that the timer no longer continues. Once you resume, the timer will continue. If you wanted just a new puzzle altogether, you can choose it. That allows you to start it. And you can choose whether when you click, you insert a number or not. You might be able to just click in there and then type in the number. If you do this, you also have some highlighting options. You can highlight numbers, or you can highlight the rows, or you can highlight all. Rows is a little interesting. It plays weird with the inserting numbers. So definitely something to work on later for me. Nonetheless, I am a fan of highlighting numbers. What that does is as you click on things or use your keyboard to flip through the numbers, you'll see that they should light up wherever they exist on that particular puzzle. And since we allowed insert, if you find one that you can place, for instance right here, just clicking should insert that number. So it's been pretty interesting. You can set up easy, medium, and hard difficulty. That determines how many numbers are on the puzzle at start. And that's because we generate the entire board at the very beginning. And when I release the information to the puzzle, I actually remove a certain number, and that determines how many gets removed. Of course, more are removed, the harder the difficulty that you choose. So with that, this is the end result at this point in time. I want to share with you the code for the algorithm that generates it and how I got there. The first thing to note is how I created the board. The board here is an array of arrays. So we have 9 digits, 9 separate integers in here for each one. I set a blank board to be all zeros, and in the logic I have it set so that a 0 gets interpreted as a empty string. So with that, if you look at the actual board itself over here, this is the HTML, of course, you'll find that I've got a table, which is square one, and this table consists of 3 rows and 3 cells. So in that sense, you have your 9-cell square that then, of course, we repeat 9 times, right? You have 3 across the top, 3 across the middle, and then 3 across the bottom. And the naming that I gave them, this is row 0, column 0, all the way up through row 2, column 2. And that means that when we're populating these cells as we go along, it's going to go through the top 1, 2, 3, 1, 2, 3, 1, 2, 3. And that's it. Those are our squares, our cells down here. So in order to populate it, let's go back to Sudoku generation. We're going to go through some interesting methods, and I just want to talk about the algorithm in particular. So all that I've got here when I'm generating the board, we just determine what square one is, and then we assign the board values to square one. This second one here is me managing where that square actually goes, and that basically provides the offset, because you have those 3 that we're assigning. The question is, does it start at index 0, index 3, or index 6? And the same with the rows, right? Does it start in row 0, row 3, or row 6? So that's what is determined by that. It's just a switch statement that determines where a square actually starts. And the entire logic of this is built on creating a good square. That took out the most challenging of the logic, actually, because my end result is going to be a good square because I know that 1 through 9 in that square are my only options. So instead of validating a row against multiple squares, instead, I already got my square and I just need to validate it against the rows and the columns. It made for a lighter logic problem. So with that, let's start here. This is the beginnings of my failed algorithm. I started by creating this one, and the intent under it was to begin with a loop constraint, a source, a destination, and what are my possibilities? This sounds a little odd. Let me put those in context here. So if you've got square one already determined, which I'll show you the code for in a moment, it's very easy, very straightforward, because it's just randomizing the locations, right? So if you've already got square one already determined and you want to put those numbers, right, we want the exact same numbers into square two, but we want to do it with restrictions, right? We have to make sure that the top row does not go into the top row, for instance. In that sense, then, I would have the loop constraint. Let's say that we only want two numbers from the top row of square one to go into the middle row of square two. We want to split them up, right? Two in the middle, one in the bottom. So that's my loop constraint, is for the middle row, it would be 2. And then the source would be the first row of square 1, and the destination would be the second row of square 2, and then the possibilities would be the contents of the top row of square 1. Does that make sense? So here we would have like the 5, 2, and whatever else this is. And if we only want two numbers, then let's say it's the 5 and the 2 that would get selected, and those would go in, 5 and 2. Okay. Now that means that whatever this other number is, let's go ahead and say it's a 7 there, that 7 has to go in the bottom row, right? So now for the next one, when we're assigning the bottom row one, we would have to put that 7 down there because we can't put it up top. And then now we have a new loop constraint, and that is we can't put the bottom in the bottom. We have to put the middle of square 1 in the bottom. Now, are you seeing how complex this is? It did not work very well. I saw it through and it was sufficient. It actually did work just as well, basically, as what I have now. It was also incredibly complex. This is a lot. And all that this determines is the placement of those two numbers. That's it. This is the generic version. So this one is one where you just put in a source, you put in a destination, you throw in the possibilities, and you let it know how long you want it to run. So this is the end result, which is as streamlined as possible. And it was still so complex. It's incredibly hard to explain this. So we're not using it. I left it in there because it's really cool to see where we started. What we're actually doing is starting here. Determine square 1. First thing that we need is to figure out what possibilities we have. And to start with that, I'm just copying numList. numList was right up at the top here. And all it shows is 1 through 9, right? Those are the possibilities of any given square, row, or column, right? The numbers 1 through 9. So with that, we're going to copy that in, determine square 1. We're going to copy in that as possibilities. Our square 1, since we're just starting, is going to be an empty array. There's nothing there yet. And we're now going to iterate through this list of possibilities. We're going to iterate through it, and we're going to decrement from the very last index. So we're starting at index 8, and each iteration, we're going to drop it down 1. So then we'll go to index 7, 6, 5, etc. We're not actually grabbing that last index, though. We're just working off of the length, essentially. So, and the length is going to be changing with every iteration. That's the kicker here. We're going to get a random number, which is dependent upon possibilities.length as the maximum number that it could possibly be. That random number ends up being the index that we're going to pull out of the possibilities list. So the first thing we're going to do is we're going to push it onto square 1, which means that in our first iteration, whatever index we grab is going to come out of possibilities and get pushed into square 1. We're using a push to do that here, and we're just grabbing that number, whatever the actual number is, and then we're going to take the index and we're going to splice it out. We're not using it anywhere. Splice does return that value, but we're not using the return value. I just wanted to use it to delete that particular index from the possibilities array. So with that, once we're done, we should then have an array of that is called square one, which consists of the exact same numbers that were in numList, i.e. they're exclusive 1 through 9, but because we got them randomly by using a random index, they're now completely shuffled. And that's square one. That's all there is to it. The rest of the squares are slightly more difficult. So for the rest of them, we need a square number. And let's see here, that's determine square number. Where did that come from? So we let square one equals determine square one, let square two determine square, and then we put the number in, 2. And then the next thing we do is we assign the board values, and we put in the square and what the square number is, 2. So we'll look at determine square first, and then we'll look at assign board values. Assign board values is right here up top. So determine square. We have the square number that comes in, and we use that square number to get the starting position. And then all of that this get starting position does, it's a switch statement that determines the starting row and the starting column. And like I said, that's because we're going square by square, right? And then we're going to grab square options, and we're determining these square options based upon that starting row and starting column. And we're sending it into get square options. So here is the square options function. Our options is going to be an array of 9 arrays. We're creating one array for each cell. Each cell has multiple possibilities, right? If this were square one, then the very first one could be 1, 2, 3, 4, 5, 6, 7, 8, 9. However, the moment that 1 is selected, then the options must change, right? They must become 2, 3, 4, 5, 6, 7, 8, 9, and exclude the 1 that was already selected. So that's what we're doing here, is we're just going to look through the rows and the columns and determine what could possibly go into this cell. That's what we're doing there, so that we can just get an array of options for each individual cell. So to do that, since we're working on the square by square thing, each of our for loops are going to be sets of 3, 0, 1, 2, 3, 4, 5, 6, 7, 8. And I need to grab the column array, because see the rows and the way that the board is set up, it's just like, what is that array, right? That's the row. But the column is that index, the same index from each of those different arrays. So that's what this is. It just creates a column array, an array that has the figures, the numbers from that particular index in each of those arrays. And then we set this options, the index, whatever index we're working with. And we determine through adding in the column array and the row array, determine cell options. And determine cell options, where'd you go? There is another smaller array, or a smaller function. We take these two arrays, we know what numbers are possible. And I'm calling this available because that's what we're going to return. We're going to return an array of available numbers. Those will be the options for that cell in the end. And all we're doing is going through, again, starting at the final index and decrementing. And this time we're actually using it. And we're just checking, does the column array include that particular number? If it does, then we splice that number out of the list of available numbers. And then if it isn't in the column array, then I check if it's in the row array. And again, if it is, we splice it out. If it's not, we do nothing. And it just rolls down through this set of numbers and splices out anything that is present in either that column or array, returning what's available. So that gives us whatever the options are for that particular cell, and we return it. Let's go back up. This was get square options. All right, assign values from options. So this is the more complex of functions because it has a lot of callouts. It goes off to other functions a fair bit here. All right, assign values from options. We send in square options, and the square first starts out as a zeroed out array. That's just 9 zeros. And then we go from 0 through 9, well, 0 through 8, whatever. We want to figure out what is the smallest cell. So within that array of arrays, whichever one has the fewest number of possibilities, I want to assign that cell first. You can imagine if there's only one that can go here, but there are 8 that can go there, if I were to assign that particular number to this other one that has many other possibilities, then I just caused a problem, right? Like I need that number to go here. So this is the way that we determine that is first off, we find which cell has the fewest number of possibilities. And then within that, we go to which number to assign, which of those numbers within that possibilities of the smallest array or the smallest possibilities array, which of those particular numbers have the fewest places that they can go. That will determine which number we have. So we've now determined the number and the cell. So then we go for the square and we put in the smallest cell is equal to whatever number that is. That's simple. Of course, in the get number with fewest options, I did have to randomize that. Same with the get smallest cell, because there might be 2 separate cells that have 2 possibilities. And sure, they might be slightly different numbers, but 2 different cells with 2 possibilities, which one of those 2 do I assign, right? And then within that, maybe both of those have 2 separate places that they could go. And I, again, need to randomize which one I select. We don't want it to have patterns that force a 2 is always here and a 5 is always there. So randomizing each of them all along the way. So square options then. I'm going to modify my square options every single iteration because we just picked a number and we assigned it to a specific cell. So now remove number from other options. This means that whatever number I just assigned, I'm going to go out to another function here. And all I'm doing is iterating through my square options and I'm removing that number. So if I assigned a 1, I don't want to have the opportunity to reassign a 1 in any of the other cells. So this just pulls it out from each of those other cells options. And then of course, that new array is what comes in here. And just to signify that we're done with this particular cell's assignation, then I am zeroing that out as well. So we're just making that a completely blank array. We're done with it. Once we're through with all 9 numbers, then we have our square. That's really all there was to it. So just bit by bit, working through what are our possibilities, which one has the fewest, which of those numbers has the fewest places it can go, randomize things along the way, remove that from everything else, and just keep iterating through. So this is the algorithm. It works surprisingly well. At the same time, it's not perfect. It's far from perfect. I wish it were. There's plenty of code in here. This is just the generation code, and it's going to end up being a little over 400 lines. But the reason why I say that it could be better is if I hit new Sudoku here, and we look over at our F12 possibilities, what we're going to find is that there is, let me see if I can show you the console here. Good board percentage. 0.109588904. That's a 10.9% good board percentage. That means that in order for it to actually present a good board to the end user, it generates 10 separate boards, and that 10th board is the good one. It's not the best. However, I love it. When I first started this one, I had set up like that second square, right, where I was pulling things from specifically from the top to the middle and the bottom, and I was filling in the gaps. That third column, I set it up so that it would just read the first 2, like whatever was in the rest of the row, right? The top of the first square and the top of the middle square. Then it would subtract those 6 numbers from its possibilities, and then it would just randomize which numbers go here. I don't know how it happened, but for some reason, it would force specific numbers to go in specific locations, like every time. It was just so frustrating. It had a preference. and I was able to stamp that out by adding in a little bit more randomness. But it was truly finding this algorithm that is just 100% pure random that I was able to finally get rid of those tendencies. It just wasn't quite right. So yeah, that's been my journey. It's been a lot of fun. It's been challenging. I felt like quitting numerous times, of course. It's taken me a while because I'll pick it up and then come back like 2 weeks later and not really remember exactly where we left off, you know. But it's been a lot of fun, and I've got it to a state right now where it can be played, and it's kind of fun. It's a good diversion for a couple of minutes each day when you're waiting in line or something. If you're interested in hearing more about the creation of this and the creation of those features, what I have done, what I'm intending to do, please drop a comment below, hit that like. I appreciate y'all coming on this journey with me to talk a little bit about the algorithm behind Sudoku. My plans in the future, just to throw those out there, I'm looking to work on back end. So because of that, I've got a new domain altogether. And on that domain, I am intending on creating an actual back end. So I want to actually have a database where we can have users with names, passwords. Man, I want to know what difficulty do you play most. I want to give you some options for your defaults for difficulty and for highlighting. I want to record times so you have an average time across each difficulty. I want top 10 boards. I want to have it set so that you could play a board and then I could play that same board, and we could like basically go head to head on time and let each board have its own leaderboard, for instance. Yeah, it should be pretty cool. And I've got some of it in place already. It'll probably take a while before it gets fully fledged and fully built out. But like I said, I picked this project because I want to keep working on it. So it'll be fun to see where it goes in the end. I'm looking forward to it. Again, thanks for watching. Hope you have a great day.